In this lesson, we are working with solving systems of equations using the elimination method, part 2. You will use the same steps as in the previous lesson with solving systems using elimination. However, sometimes it is necessary to multiply one or both equations by a number in order to produce opposites that will eliminate each other. So looking at our first system, we have the equations, the opposite of x plus 4y equals negative 22, and the opposite of x plus 8y equals negative 38. So both of these equations are already in standard form. So I can see that my x terms, I have a negative x and a negative x. And for my y terms, I have a positive 4y and a positive 8y. So neither of our x terms or our y terms are opposites. So in this case, for us to use elimination, we need to create a column of opposites. So with elimination, and the same with substitution, there's more than one way to solving the system using a given method. So just because I work it out one way in this video doesn't mean that that's the only way to work out that system. So I want you to keep that in mind as we're going through some examples today. So I'm going to choose to focus with my x terms and making those opposite. So if I have a coefficient of negative 1 in this top equation for x, and in the bottom equation I have a coefficient of negative 1. So if I want to make those opposites, then I would need to have one coefficient be negative 1 and the other coefficient be a positive 1. So in order to do that, I can multiply by a negative 1 to make one of those a positive 1. Because if I multiply negative 1 by a negative 1, that would give me that positive 1 coefficient that I'm looking for. So once again, there's more than one way of doing this, especially since both of the coefficients are negative 1. It doesn't really matter which equation you're going to multiply that negative 1 by. So I just chose to multiply that top equation. So I'm going to multiply that whole top equation by negative 1. So when I do that, I'm going to have negative 1 times the negative 1x, which would give me a positive 1x. A negative 1 times a positive 4y, which is negative 4y, and negative 22 times negative 1, which is a positive 22. So I have this new equation once I've multiplied that whole equation by negative 1, which is x minus 4y equals 22. So once I've multiplied by that negative 1, I'm kind of finished with that top equation. So now I'm going to focus working on these two equations here. So I'm going to set them up in a table, and here then I can see that I have a positive x and a negative x, so that would create that 0x, or those terms that eliminate one another. So now I can go ahead and combine the rest of my equation. So if I have negative 4y and a positive 8y, I would have a positive 4y, and positive 22 and negative 38 would be negative 16. So then I would divide both sides of the equation by 4, and then y equals negative 4. So now I can choose one of these equations to substitute this value of negative 4 in for y. So I just chose to work with this equation, so x minus 4y equals 22. I'm going to then substitute this negative 4 in for y. So I would have x minus 4 times negative 4 equals 22. Negative 4 times negative 4 would be positive 16. I can then subtract 16 from both sides. And so I get the value of x to be 6. So the solution to this system is the ordered pair 6, negative 4. Okay, let's try another one. So if we had the system 12x minus 4y equals negative 84 and 4x plus y equals negative 14. So these equations are once again already in standard form. So I have my x coefficients of 12 and 4 and my y coefficients of negative 4 and positive 1. So the x terms are not opposites and neither are the y terms. So I'm going to have to make one of the, focus on the x's or the y's to make those opposites. So in this case, I'm going to work with the y's. And so if I have a coefficient of negative 4 and I want the opposite of that, then I would want this one to be a positive 4. So that way I would have that column of opposites. So if I have a coefficient of positive 1 right now, then I would need to multiply that bottom equation by a positive 4 in order to be an opposite to that negative 4. So I'm going to multiply that bottom equation by positive 4. So 4 times 4x would be 16x, and 4 times y would be that positive 4y, which was our goal, equals negative 14 times 4, which is negative 56. So now I have my new equation after I have multiplied that equation by positive 4. So I can set those up in the table, so using my top equation and this new equation here after I multiplied by 4. And now I can see that my y terms, I have a negative 4y and a positive 4y. So those would eliminate one another because I would have 0y, so I can eliminate those terms. And then combine my two equations. So 12x and 16x is 28x, and negative 84 and negative 56 gives us negative 140. I can then divide both sides of the equation by a positive 28, and so x equals negative 5. You can choose one of the equations to substitute the value of x in for, and so I just chose to use that top equation of 12x minus 4y equals negative 84. I'm then going to substitute this value of negative 5 in for x in that equation. So I'd have 12 times negative 5 minus 4y equals negative 84. I would multiply 12 times negative 5, which is negative 60, minus 4y equals negative 84. I can add 60 to both sides of the equation, and then I'm left with negative 4y equals negative 24. Once I divide both sides of the equation by negative 4, I would get my y value to be 6. So the solution to this system would be the ordered pair negative 5, 6. So now I want you to pause the video and work out these two practice problems using the elimination method. When you are finished, push play to check your answers. Okay, let's see how you did. So for the first system, negative 2x plus 4y equals negative 8 and negative 8x plus y equals 43. You should have gotten the solution negative 6, negative 5. And for the second system, 4x minus 5y equals 72, and 2x plus 15y equals negative 104. You should have gotten the solution 8, negative 8.